Good afternoon, everybody, and welcome to this event hosted by Engineers Ireland. This is the first of a four-part series from Engineers Ireland entitled Emerging Trends in Digital Engineering. This first event is focusing on modern methods of construction. To put modern methods of construction in context in terms of Engineers Ireland, I would refer to our own State of Ireland report 2021, which was published in late December 2021. This dealt extensively with the topic of what they call digital construction or modern methods of construction. The Irish government is now embarking on the implementation of a national development plan, a very substantial piece of work from 2021 to 2030, a Housing for All strategy, published late last year also, and a climate action plan. This is a major investment program of at least the expenditure of 165 billion, an unprecedented amount in terms of supply chain for the construction industry. To meet this huge ambition, we in the industry need to move away from manual processes and traditional forms of construction to smarter, more efficient, and more sustainable forms of delivering on these plans. In short, we need to get more digital. And that in turn will drive better productivity and sustainability. Indeed, the three main pillars of construction nowadays, certainly new generation construction, are digitization, leading to greater productivity, and thirdly, but equally importantly, sustainability. With that introduction, I now want to introduce our two speakers for today, who will deal with their respective experience on modern methods of construction. And indeed, knowing their background, they have a lot of experience and a lot of expertise, and we're really looking forward to hearing both of them. Our first speaker is James Young, Chartered Engineer and Director of Engineering Services for Evolution Innovation, one of Ireland's leading consulting engineers in modern methods. James will be providing a talk on the digital design process from the perspective of a modern methods of construction project, consultancy, with a wealth of experience in this whole area. James has been working in the area of MMC, that's what we call modern methods of construction for short, for the last 16 years. He has worked on MMC projects nationally and internationally in that time. During the last 8 years, he has been working with Evolution Innovation towards becoming the leading MMC consultancy in Ireland. Today, he is going to give a brief outline of the digital processes which Evolution adopt specifically for MMC projects, and also the future trends where he sees the digital element playing a very important and major role. So thank you very much, James, and over to you.
Thank you, PJ. Can everyone see that page? Yeah. All right. So thanks, everyone. So today, so my name is James Young. I'm the Director of Engineering Services in Evolution, and today I'll be talking about, emerging trends in digital engineering for modern methods of construction. Just a brief professional history about myself. I graduated from MTU in 2006, and straight out of college, I worked with Fusion Building Systems in Cork, who were an MMC company, one of the first of its kind at the time. For about 4 years, I spent time in Australia after the crash, just to keep my professional experience developing, where I also got involved in MMC. And ever since 2013, I've been working with Evolution. I chartered engineer since 2014, and the NHBC Stage 2 is a third-party certification system in the UK for MMC systems, which I'm on the list. The main objectives I have for today is just a brief outline about Evolution, discuss the various categories of MMC systems, give a brief overview of the current application of digital tools that we use in our design, and just future digital trends in using MMC that we see coming down the line. Our mission is to promote MMC offsite construction to the industry and to the general public, and to ensure that the offsite construction is of the highest quality and complies with building regulation requirements and standards. In Evolution, we have 4 departments. The structural and the BIM is the primary department I'll be referring to today, but just a brief outline of the other departments. We have a building physics and sustainability department that specialize in things like, we have NSAI accredited thermal modeling, daylight analysis, dynamic simulation, overheating analysis, condensation risk analysis, as well as your BERs for domestic and non-domestic. We have a very significant product development and certification department that assists many systems such as MNC systems get certified with certification bodies. And we also get involved in assisting companies getting third-party fire testing, acoustic testing, and so on. And we also have a quality engineering department. So from an MMC perspective, our structural engineering consists of both structural engineering and BIM design. We are MMC construction and manufacturing experts and work both in 2D panelized and 3D volumetric systems. As well as the engineering, we also work in the BIM design and the manufacturing detailing design end of it as well. We would be both nationally and internationally recognized as experts in the MMC, and we work mainly around the philosophy of design for manufacture and assembly. So what can MMC provide? MMC can provide many things. It can provide your housing, your mid-rise residential, all the way to the tallest modular buildings in the world. A number of years ago, a framework definition was set up to help the various systems be understood better and have a more regularized terminology. These categories are set up to try and encapsulate everything relating to MMC products, and we end up with 7 categories that you see there. The 2 main categories that we concentrate on is category 1, referring to pre-manufacturing 3D primary structural systems, and category 2, mainly for structural steel systems. Currently in Ireland, there's a few category 1 and a number of category 2 certified systems in steel frame. Darragh, who will be talking after me, is from Horizon, who will be one of the leading 2D panelized companies in Ireland at the moment. When Evolution work on any MMC project, we have a specific design process we use to deliver the projects from conception to completion on site. The process in which we work is designated to cater for the needs and pre-manufactured elements. The timing of manufacturing is different to traditionally built structures, and this has to be taken into account. So the 4 main items that cover this is your structural specification, the pre-construction model, manufacturing, detailing, and assembly drawings. So I'll briefly go through all 4, but Darragh, I'm sure, will go through the final 3 points of mine in greater detail in his presentation. At the structural specification stage, this is digitally modeled, but it's digitally modeled in similar ways to if it was any other building. However, as we generally work with systems required to be manufactured off-site, the digital design process of the physical elements is set up to suit the off-site design systems to ensure a high degree of accuracy is achieved and time efficient to allow the manufacturing ahead of site delivery. Out of that digital model that we would produce would be your stud specification, your hot rolled steel, bracing, lintels, fixings, and obviously your foundation loadings. And out of that, we develop an IFC model from our software analysis that can be moved on to the next stage, where we get into more the area of DFMA, or design for manufacture and assembly. When Evolution works on any MMC project, we have a specific digital design process we use to help create the final manufacturing elements by the MMC supplier. Obviously, we will always start with an architectural model that more and more now is coming to us in a digital BIM format, but where we still get your traditional 2D drawings. But from that, we would develop a pre-construction model and create a model that is developed around the architectural model, but creates the information applicable to what the MMC manufacturer is going to produce. So within that, all families are parametric and are designed within the model to allow for each element to be tracked, procured, and manufactured. Again, Darragh will go into this in more detail, but various elements of a process with this model, typically for us in Revit, is to get to a stage where we have a fixed frozen design to start the manufacturing process. Using specialist software, the structure is produced to allow for all the manufacturing elements to be fabricated, involving high degrees of accuracy. So you develop your manufacturing information, your assembly parts, fixing quantification, your clash detection, and the digital information that's used to quantify then the material that one needs, and confirm program dates as well as other aspects of it. You're exporting hot rolled steel elements to your fabricator, and I'm sure Darragh will go into more detail, your assembly drawings for your walls or your floors that go down to the factory floor. The important thing when you're talking about MNC projects is obviously it all has to be pre-manufactured, but it has to be pre-manufactured to a high level of accuracy, of some of which I've highlighted here. But to get to that stage, it's important that the levels of information through digital formats is developed and put together, working with the design team to ensure that when we get to manufacturing stage, these are the levels of accuracy that we're able to deliver and achieve. Because precision engineered solutions require precision design processes. These are not systems that begin on site. This begins at the manufacturing facility. And the BIM design allows for accurate designs to be integrated into a particular structure to allow it to be manufactured correctly and on time. And our BIM design process is driven to allow for this to occur. Here's another example of a Horizon project. Again, you see we're at the pre-con stage, and then we're into the manufacturing stage. So whether it's housing or large scale developments, we apply our processes as required. And these processes, as I'll touch on in a minute, drives sustainable design solutions, significant reductions in waste, time savings of anything up to 25%, even more can be achieved. In terms of Evolution's track record, specifically for MMC buildings, we have a significant track record in both Ireland and the UK, be it student, hotels, residential, educational, and healthcare. Some of the projects that we've delivered are, various student accommodation, hotels, more student accommodation, significant student accommodation projects, a significant amount of social housing and apartment developments that ourselves and Horizon are doing currently, and as well as healthcare facilities, including this one, which was done in Limerick in 2020. And as you can see, obviously it was a unique time period for a lot of support for the country, but with the processes and the design team involved, that process started on the 25th of March and delivered practical completion by the 2nd of July. So the process helped drive that rapid design. In terms of what we see next, I suppose the two main areas I would put out there are obviously sustainability and another area in terms of thermal mechanical engineering. So in terms of sustainability, Yeah, so in terms of sustainable designs, sustainable design is now a key focus on all construction projects, and it's something we're strongly committed to in driving and enhancing in our designs. This is a decarbonisation roadmap issued by the BCSA, where they've outlined a number of steps how this can be achieved, starting with design efficiency and also working its way down to things like circular economy, the emissions of the steel making, all the way down to your steel transport, fabrication, and erection. We are already collecting the digital information, as you would have seen from the information I put up before, to look at optimizing how we can produce sustainable structures. The process we have in place also significantly reduces the amount of construction waste by manufacturing in controlled environments. And as you can see, the levels of accuracy that has to be achieved naturally drives that efficiency and minimum waste. And then we're looking at the next steps in terms of, here, for example, is an output from one of our Revit models. So this is an area in terms of embodied carbon, but that is an area that we're really targeting and looking to understand as much as possible to allow us to develop design solutions that limit the embodied carbon output. We already track a significant amount of data digitally through our design processes, as you would have seen. So we are starting to learn how to apply this at an earlier stage to guide us in terms of more sustainable designs and drive the use of more sustainable materials. The other area that we're looking at in terms of a digital kind of future in MMC is the area of thermomechanical analysis, which is the analysis of a structure in under heat conditions. So it's kind of the application of testing for significant buildings down the line to potentially analyze how they perform in a fire situation. So there are two of the areas that we're kind of really looking at in terms of taking where we are currently from a digital perspective and seeing how we get to the next stage and drive it for the future, for the many challenges that lie ahead for us. So that's the end of my presentation, which is obviously brief, but thank you very much for your time.
Thank you, James. I'll share this. Let me know if you can see that. Yep. Okay, so PJ introduced me, and
just
thanks very much.
Before you start,
no.
Darragh, I'll just introduce you very quickly.
Yeah.
Darragh studied civil and environmental engineering in UCC and went on to get a master's in Imperial College in structural engineering in Imperial College London. He worked as a structural engineer in London for over 7 years, where he had the opportunity to work on a number of important projects, including the M7 office buildings and the Westfield shopping centre. He returned to Ireland in 2020, taking on the role of design manager at Horizon Offsite. Horizon specialise in light gauge steel building systems for commercial, education, residential and industrial developments. Handed you over now to Darragh. Thanks.
Thanks very much, PJ. Okay, so look, my presentation, it's going to focus on initially an introduction to Horizon for those of you who don't know what we do and what we're about. And then I'll introduce our systems and testing, and then talk about the digital process, which gets us from, say, a concept project onto site. So going into a little bit more detail into that pre-construction model and the 3D BIM drawings and what we use them for. Okay, so just introduction to Horizon. We were established in May 2017. The objective was to design, supply fully accredited offsite solution to the growing market in Ireland and the UK, and also then worldwide. So we're based in Cahir, County Tipperary, south of Ireland. It's ideally located because of the motorway, and that links the main markets there, Dublin and Cork, which are our two biggest markets. Staff numbers, we have about 60 personnel on site. 40 of these are production staff, and the remaining, say, 20 split between design, commercial, and contracts. We are one of the market leaders for light gauge steel 2D panels in Ireland, and we have a presence in the UK market also. Okay, a key selling point for Horizon is that we are a system build. So it's not just light gauge steel studs. We also take responsibility for other aspects like cavity barriers, detailing, so we can sign off both structure and fire protection to that structure. Okay, we've taken external claddings into the Horizon package for many jobs, and I'll go into more detail on that. Also, since March 2021, we are owned by ETEX Group and part of the ETEX New Ways division, right, which has opened many doors for us on research and development and collaboration with other ETEX companies. SIGMAT and EOS are in the UK, and there are 2 other light gauge steel companies which we are now collaborating with and joining forces. Okay, we've got 2 main stud sizes, an 89mm stud and a 100mm profile. So the gauge or thickness of these ranges from 1.2 to 2mm. We have 4 roll forming machines on site, and the facilities and care include over 3,100 meters squared of manufacturing internal area and 18,000, external storage meters squared external storage yard space. And we're planning to further expand into the business park. We already own much of it, but we're planning to expand in the coming years. So this is a 3D model of the manufacturing plant. The aim is really raw material in on the front, okay, in on one side, and completed panels out the far end. So there's 2 production lines with overhead gantries, as you can see there. Okay, and what we offer clients. So there's a couple of different options on the external walls, because, as I said, we're a full system, a through wall provider. So we can do a lightweight render system, which can be a greenspan aqua panel system, and also as part of that system in the factory, we assemble the light gauge steel, the insulation, and the carrier board. And on site, then that would be counter battens, the cement board, and then the render would be put on site. Most of our sites still use brick and masonry block. Usually these buildings would be a low-rise building, and we would apply the insulation and wall tie channel in the factory and deliver the panels to site, so pre-assembled. The brick block then would be built on site. We can do buildings with stone facades, and we also have not fully non-combustible cladding systems. And this is in collaboration also with other ETEX products such as Equitone. And there's also brick slip and stow cladding options. So we're continuously carrying out research and development to stay ahead of the market and also give the market what it wants. So our latest solution was a factory insulated non-combustible mineral wool panel. Okay, so the panel arrives to site with mineral wool, membrane, wall tie channel, all pre-applied. That's the picture on the bottom right there. Okay, moving away from external walls, we also do internal walls, both low bearing and non-low bearing, decking for the composite slabs, composite concrete slabs, and we design and install light gauge steel floors as well, which can be light gauge open web trusses, or it can be a C-section with OSB board. Okay, we can include the balconies, which can either be lightweight or concrete decking, roofing solutions, so light gauge steel roofs, timber roofs, decking roofs. And we also do panelized infill as well, which usually is a frame and a board assembled in the factory and lifted into position on site. Okay, so as with most modern methods of construction, the testing and accreditation is extremely important. Right? The main one for us is the NSAI agreement certificate. So NSAI stands for the National Standards Authority of Ireland. It is a state agency in Ireland, for those of you who don't know it. So it's proof to clients and architects that the product is suitable for use under Irish site conditions, and verification then that the materials and construction outlined in the certification is in accordance with the Irish building regulations. So the NSAI agreement certification, it's designed specifically for new building materials, products, processes that do not have like a long history of use. And like there's a lack of national standards. So therefore MMC and light gauge steel modular would certainly fall in under this jurisdiction. So other certification we have, we're accredited with SCI and NHBC. We have EN 1090 CE certification, and upon completion of design and installation, we also issue the specialist designer ancillary certs and a specialist contractor CS cert. And we're A rated with safety cert and a couple of others. Okay, so the heart of the Horizon system is accreditation and testing, right? So we've got 33 load bearing tests carried out with our stud profiles. So these are fire from both sides. So we've out to in tests, we've in to out tests, and the tests are carried out not in the Horizon facility, it's in accredited independent laboratories. So this would be like Effectus in Belfast or France, BRE in the UK. So our tests would be carried out with voids in the plasterboarding sockets, just to try and simulate real world effects of, pattress boxes, surfaces in walls. We've also carried out some junction testing for key junctions as well. Okay, apart from the fire testing, we also have acoustic testing done in laboratory conditions. We've over 40 tests done. So and we've got modeling done to simulate other scenarios which are similar to the test scenario. Okay, so now I'll just move on to the kind of our design process in getting, product from, say, the design and conception stage, bringing it forward to site. James has touched on this, but the first step here in the design workflow, following appointment, the first step is the structural scheme and a load takedown. Okay, so initially this is just a basic PDF markup, color coding wall types, line and point loads in each direction. That's our initial one before it gets fully digitalized. So this infogram then represents our digital workflow. It shows our information in, the information out as well. So the design team feeds the initial process based on employers' information requirements, design team, BIM execution plan. So James talked previously about getting like an architectural model. We'd get the M&E models as well. We take all of that information and create our own pre-construction model, our pre-con model. Okay, so that's the start of our information management process, and it leads to the design, fabrication, and ultimately construction of the Horizon system. So the digital delivery system then stems across our entire company, and everything is interlinked and traced back to this pre-con model, pre-construction model. So that pre-con model, it forms the basis then of all coordination with the design team. So it's an iterative process then for general spatial coordination, such as, are the walls in the right place? Are the windows, in the right place, and are the right sizes? We put in hot rolled steel sizes, make sure there's no clashes there, and incorporation of the light gauge steel system requirements, so details, to make sure it's in accordance with the NSAI approved system. Okay, so the model, it's essentially a digital twin for the information gathered throughout the design process and the basis of all fabrication data following the design. Okay, so its process is iterative, right? It's ongoing until we get sign off of the model. So it's signed off and approved from the design team. The architect has checked it, M&E has checked it, project engineer has checked it, and everyone's happy with the setting out. And then we begin to disseminate the information to form the light gauge steel framing model, the hot rolled steel fabrication model. So this So this shows that dissemination of that information. So from that pre-con model, we then internally distribute the required information to each team internally, and each team then still has full access to the pre-con model. So any changes are updated in real time. So the hot rolled structural steel, because our schemes are hybrid. Okay, we do light gauge steel, but we also incorporate hot rolled columns and beams into that as well. So the hot rolled structural steel is fed from the structural design software into the pre-con model, and then from the pre-con issued to the steel fabricators for the production of the steel drawings. Okay, and the fabrication, the ultimate fabrication of that steel. Then the light gauge steel detailers have access to the pre-con and steel model, and then they detail the light gauge steel panels around the hot rolled, ensuring there's no clashes. And because if they were working in isolation, there could be. So this ensures there's no clashes and everything is coordinated. So therefore the hot rolled and light gauge steel are coordinated from this signed off pre-con model, showing all the openings and architectural features and architectural requirements. So the pre-con model is used in our quality control and quality management procedure to verify and check each component. And we have certain stop phases where we do full checks between design and detailing and fabrication checks, and everything is checked back to that pre-con model. And then from that pre-con model, we issue out the PDF drawings and DWG drawings, material takeoffs, panel layouts to the design team. And then we use, I'll talk about the different software. So the Vertex is what's used for the framing model or the detail, the fabrication model. And for the pre-con model, we use Revit. Okay, so the Vertex software produces CAM files, which is sent directly to the roll formers for production then. So the digital delivery process is the heart really of our entire company. So with production and the access to large amounts of data, we have to manage the creation, publication, and dissemination through the construction life cycle of the project. And then this leads to information supply to the client for the operation life cycle. Okay, so all our digital data from the pre-con feeds from the design stage, inputs from site are put in, and we have an as-built model, then as-built construction model, which we issue as a federated model of the system for the client to manage throughout the life cycle of the building. Okay, just to talk about some of our structural design software. So we use Autodesk Robot, Tekla. We have some TEDS add-ins as well, but a lot of our work comes from in-house spreadsheets as well. Okay, and then in terms of our drafting software to make that pre-con model, we use Revit as stated earlier, and for the framing or detailing model, then we use Vertex. And the two models, the two softwares, can be fully interlinked, and they work together quite well. So one can be inputted into the other. Okay, so this process here just shows the flow. So we get the signed off pre-con model, and then we use that to create the framing and the hot rolled model, and then that goes down, our panels built in the factory, and we have construction on site. Okay, so this is just the same process for another project. So it's the pre-con model again, and it's framed and construction on site. So the pre-con model is the kind of heartbeat of the whole design process for us. Some projects that we've done, I'll just quickly run through one or two of these, but Bandon Road in Cork, we've done 5 blocks of 4 and 5 story student accommodation. A very successful project. It's just gone for practical completion now. And we had the Roxborough in Limerick, very good project for us a year or so ago. And one we've just handed over is St. James's Cardiology Hospital in Dublin. It's on the St. James's campus. It's a 4-story building, 3 and 4-story building on the campus for cardiology. So I'll now hand you back, I think, to PJ, and we'll take any questions or anything. Thanks for your time.
Thanks very much, Darragh, and another excellent presentation. We have a Q&A platform there where you can place your questions, and I'll take them, or if you want to raise them separately in the chat function, just put your questions into the chat function. I have just a few comments on the 2 presentations myself, and one question. Obviously, you know, we're fast moving in this direction in terms of modern methods, the main driver of which is the relative lack now of wet skills. So the days of bricks and mortar are fast disappearing. We now have to move to steel frames or timber frames with infill, and you know, there's a major skills deficit in the country, and that's what's driving modern methods of construction, together with the need for greater efficiency, driven by digital, driven by building information modeling, and also driven by the climate action plan in terms of sustainability. And I was glad that James mentioned the whole area of embodied carbon, which is going to become a big issue. I would just like to ask James, you know, does his model count the embodied carbon at the moment? Because I know that the Office of Government Procurement is going to use BIM 6D to assess embodied carbon on tenders. And there will be a criteria on the green procurement rules to be issued shortly by the OGP, which will help to decide on who gets the job. So it's going to move away from price only towards quality, and part of the quality criteria will be the whole embedded carbon area, which the BIM model will supply to both the designer and to the assessors. But I just asked James around that. And secondly, what emphasis has been given to the quality of insulation in the modern methods and your experience post Grenfell, and also bear in mind that insulation, some types of insulation, apart from fire risk, also happen to have high levels of embedded carbon. Thank you.
Yeah, thanks, PJ. I suppose in relation to the first question, we've been hearing strongly anecdotal evidence, especially in the UK at the moment, that a lot of decisions are being driven by more about sustainability almost, or it is as important as cost. And I suppose where we've been kind of pretty lucky, the process that we discussed about there, that's actually a process that we've been doing for 15, 16 years anyway, because we've always had to develop the 3D model to develop the off-site structures that had to be made and modeled. So we've a very strong sense of collecting the data that we need, and as we show, we're strongly kind of studying and setting up our pre-con model in particular, and using kind of outputs from the likes of Revit, and using other, like there's other aspects of that as well. And we also have our own in-house sustainability team in terms of looking at LCAs. So it's one we're strongly kind of developing and studying, but we feel it's already a natural part of what we do anyway. So it's a case of just really analyzing and quantifying what that is, and really kind of getting it down on paper so it's clear for everyone, more importantly ourselves, you know, in terms of quantifying that.
Thanks very much, James. Darragh, have you any comments to make on that?
Yeah, just that, just to back up what James said. So we're all really familiar with Revit and what that can do. It can give you volumes of different elements. But our Vertex software, so our fabrication model, the detail in the fabrication model, that is extremely detailed software. It can give us the full quantity of screws, rivets, you know, that are used on a full job, you know. So we have the data, and we're only recently in the last year or so, in collaboration with James, starting to kind of put carbon figures to these quantities. So Revit is one thing, but we've got that Vertex fabrication software, which can give you things that Revit wouldn't do, that you'd have to approximate from Revit. So we know the exact tonnage of light gauge steel. We know the exact wastage of any material, which would be very, very little. And the same for volume of insulation, all from that Vertex file, so we have the data, and we're now processing that, to get the carbon content, the embodied carbon.
Okay.
And then just sorry, Peter,
yes,
you had a second question there, just in relation to insulation. So I suppose obviously, there's within building regulations, you're allowed, well, you can use the likes of PR insulation up to a certain height and so on. But what we have been seeing more and more is mineral wool insulation being used in areas where kind of lower rise buildings. Then many clients are making that call, and I think the challenge then is just trying to apply that insulation. One, obviously it has a thickness element from a thermal perspective, so it's much thicker than say a rigid insulation board. So we're already kind of working on areas around how to evolve that onto the systems in terms of testing or applications or whatever the case is, and kind of working with each of the clients as they request that. But it's a very important thing to recognize. So I think the height of use is probably going to come down a bit lower than is currently allowed in the building regulations. And I think a lot of companies are already kind of making preparations to put that into their buildings now.
Okay, thanks, James. There were two questions there on the Q&A. One from Ger McInerney to Darragh. How does your system handle design change?
Yeah, so there's two things really when you consider design change. There's design change during the construction process, right? And then there's design stage, let's say 10 years time or something like that. So during the construction process, everything is manufactured up front. It needs to be coordinated at an earlier stage. And, in fairness with architects, they're relatively on board with this and they have their coordination done. The sticking point we often get is with M&E. Now, not to offend anyone here, but often the M&E is sorted out by the contractors on site, and it's an initial concept is put together, but then the real details of size of penetrations, holes, and that sort of thing is done on site. With light gauge steel and Horizon, we like to bring that forward. So it's about engaging with the clients and bringing that forward as much as we can. To get that coordination process and all the openings coordinated before manufacture. Now, we can do site changes, and we do site changes. They happen. So, we can put loose stud in on site, but it's not desirable. There's no problem with it, and there's a couple of say patented elements that we can use that make our life easier, little connections and details. But we try and minimize the on-site, the on-site changes. And then sorry.
Okay, Darragh. I agree. You need to minimize the site changes.
Yeah.
I think I want to move on because there's well over 200 people on this call, which is quite exceptional. Mind you, there were over 300 actually registered, which was also exceptional. It goes to show you the interest in this particular subject. Going back to James, John McGowan asks, your dimensional control is impressive. Has this led to faster completion and a reduction in RFIs? Requests for further information.
Yes, it has led to faster completion. I think in terms of the processes are driven mainly by one, to get yourself to an end goal of having a highly accurate model going to manufacture. But the design process that both myself, Darragh, have outlined is also to bring the whole design team with us, who quite often will be working on an MMC project for the very first time. Now, that's becoming less and less an issue now, but we'll still come across, as I said, an M&E consultant or an architect that's looking at it for the first time. So the process is as much for ourselves as it is for them to kind of guide them, this is what we need. And then, yes, look, it doesn't eliminate RFIs, but what you do get is you get a very extensive RFI list at the very, very start. But what also has to be appreciated, that RFI list has to be ticked off much, much quicker than a traditional build, because obviously we have to make this to get the site.
Okay, thanks, James. Darragh, just to confirm, this is from Padraig Carrig.
Yeah.
Just to confirm, is it the Vertex software that tracks all the embodied carbon, or do you use Revit for tracking this aspect of the project? Or does Revit track some of the embodied carbon and Vertex handles other aspects? Please?
Yeah, so it's the last point there. So it's both models feed into an embodied carbon tool. So Revit would have certain elements like concrete, meters squared, decking, meters squared, areas of OSB, or all the non-light gauge steel items, right? And then Vertex would have the light gauge steel items. So all the light gauge steel tonnage, the connection details, screws, rivets, things like that. So it's a combination of both.
Okay. Keep the questions going, guys, because we have another 5 or 10 minutes for those, and then we'll have to close up around 5:02. James, a question, and possibly Darragh, but I'll ask James first. A question from Derek Sinnott. What are the current challenges and constraints that may impact scaling up of project delivery? And conversely, what are the main opportunities to scale up design and delivery?
Yeah, well,
James first.
So like in the world of site labor being a challenge, it's in particular in large housing schemes where you might have, you could have 100, 140 housing scheme where there might be 4 housing types. So four designs and 4-handed designs that could be done. And that almost at the click of a button to keep rattling those out in terms of mass production of housing in particular that is repetitive. So the system and the process itself really lends itself well for that kind of mass production, or kind of being able to scale up to meet the demands that people are looking for. So
Hey, James, anything to add, Darragh?
No, that's exactly it. That's where the
fine.
system.
Okay, we move on to Manus Bester. Thank you for a very informative presentation. Mind you, there are loads, dozens of comments coming in congratulating you two guys without asking any questions, just to let you know that. But Manus Bester says, thank you for your very informative presentation regarding embodied carbon assessments. There are various stages. Does your current software solely focus on the product and the embodied carbon involved, or is it possible to do a life cycle assessment which also focuses on the post-construction stage, including the use and end-of-life products?
Well, I think if you, I kind of indicated there's a guidance from the BCSA in the UK where it kind of breaks down the steps. So like, whereas design efficiency and manufacturing is just going to be one part of this. Like obviously more efficient design maybe is a bit less steel, to be used and less energy to use that. But then it's all the way down to, Darragh's team kind of, limiting the amount of transports or deliveries that are required to site, and actually through MMC, you can minimize the amount of deliveries that are needed versus a traditional build. So it's the whole thing. If you take that BCSA kind of guidance, it's the whole element, not just the components that make up the structures that, say, Horizon would make. Okay.
Anything to add there, Darragh? Or
no, that's
fine.
Yeah.
Okay. Michael Regan asks, do you have data comparing savings and man hours consumed on site in comparison with traditional construction?
Yeah, look, there'd be data there from other bodies like that I can get and circulate, that can be circulated to Michael. Yeah.
Okay, and another question from Daryl Keeley. What is the name of the BIM enabled carbon counting tool software that you're currently using. Thanks, Darragh Keeley. I think maybe offline, you better go back to him offline on that.
It's an in-house one, isn't it, James?
Okay.
Yeah,
It's a proprietary product. Okay.
It's
Daniel
developed.
McCrum, thank you very much for your presentation. There are a small number of category 1 and 2 companies in Ireland based on the presentation. So how do you think we can grow this?
Well, I thought that Darragh wouldn't be too, like Darragh just point that like there's Horizon, but I suppose the key thing is category 1, like there's a significant amount of category 2 companies, and I think, you know, it's good that the market is there to allow those category 2 companies to develop. I think the key thing is kind of, you know, category 1 is 3D modular, and, you know, a lot of people think, well, you know, geez, we need, you know, we need offsite. Why aren't there more modular companies and so on and so forth? And I guess what people really need to appreciate with modular companies is the upfront cost, the operational kind of need to keep those companies going and develop and evolving. So, you know, the more the market kind of accepts what's out there and grows with it, and is willing to give it as more work to allow it to develop and grow, that'll give it the opportunity to develop, to give more options that are into the market. And I will say that of the category 1 and 2 systems that I did show, there are more coming down the line as well.
Yeah. Okay.
Just to add on that one.
Sorry, Darragh. Yeah, go ahead.
Like I think like it needs to start right from the planning stage. Like developing suitable buildings for offsite. You know, where offsite would be competitive on the price is when you have repeating buildings, like James talks about, a housing estate, let's say 100 houses, but there's 4 house types. You know, we designed that 4 times, and the factory can repeat that process over and over again. That's where the price gets really competitive. And then also the same way with apartment blocks, repeating floor plates, you know, with tracking load-bearing walls. So it starts right from the concept, I think, in getting suitable schemes, and then educating architects and, say, developers to take this MMC and you know, see the benefits, you know, because yes, some projects might be slightly more expensive, but you're saving up to 50% on your site, say your structural scheme on site.
Yeah.
So that needs to be offset.
Yeah, architects, engineers, and developers.
Yeah.
Darragh, don't forget the people in Engineers Ireland. David Morrissey wants to know, apart from design, do you feel that other digital technologies such as augmented reality, drones, etc., will play a role in OFC, I suppose that's OSC, to enhance project delivery?
Yeah, I just seen there, PJ, I would say that David's question and Darius's question would be relatively similar. I guess my answer to that is, look, absolutely. Now, I have seen a number of different companies try to, especially on the modular side, try to introduce almost paperless processes in a modular sense by using these kind of HoloLens helmets and things like that. And look, to date, I've seen all these good ideas and kind of concepts, but I personally haven't seen it actually really rolled out. But there are a number of, you know, there's definitely a number of companies that like say myself and Darragh will be looking at. But there's in the UK where we do see that there are digital softwares that are being used when one goes to site to review something, that they have a model off the phone or the iPad and they take a look at something, and they're able to create a kind of, I think that's augmented reality situation from a design model to assess, well, okay, that's there, or that shouldn't be there, or whatever. So it's in its early stages. It is there, but it'll take time.
Okay. Next question. The design from Eamon Conneely. The design process is hugely time consuming, especially the detailed design phase of the process. Does either speaker feel that software providers such as Autodesk are doing enough to improve their software products and allow engineers to spend more time defining the designs and less time on administrative type work? Please, either of you or both of you.
Look, go on, James.
Sorry, I suppose I suppose Eamon's question is probably a general question. I suppose the unique challenge we have is sometimes in the world of MMC that like the softwares that work for MMC can be relatively limited. However, Revit, we do use, Revit for that. Look, like, I'm not sure how to say that it could, you need your document control, to represent everything that you're doing, I suppose, to be honest, I don't have an answer to that question as such, really.
Just in terms of what I can say is, I know Vertex, like it's not a massively well-known company. It's a small Swedish company, but it specializes in light gauge steel framing, and they're very, very receptive to changing the software, changing the code behind it. So they've incorporated a number of our suggestions, probably 10, 15 items that they've personally changed and updated to suit us, so they are quite receptive. Autodesk is a bit slower.
Okay, but there's always room for improvement, is the message.
Yeah.
Just on the Manus Pestus back again, Darragh, question for you. From a total weight point of view, I presume projects considering light gauge steel solutions are considerably lighter compared to traditional methods. From your experience, is that a major saving on the substructure design?
Yeah, we've changed a number of schemes from pile design to a shallow foundation design. A number of schemes. So the saving there, James, you might correct me if I'm wrong, but it's somewhere around 15% or approximately. Or
yeah, we've seen like it varies depending on the project. We have seen some some extreme instances like savings of up to 40%, but generally it is kind of 15 to 25%.
We have to wrap up, guys. There's still questions coming in and lots of lovely messages that you can see yourselves on the screen in the chat. It's all excellent presentation. Thank you, guys. Well done. And I want to thank you sincerely, both of you, on behalf of the audience and on behalf of Engineers Ireland, for giving us your presentations. And I assume the presentations will be available in some shape or form. Yes, no?
Yes.
Thank you very much. And thanks again to Engineers Ireland. We're going to, we have 2 minutes to go, and I think probably some people are on their lunch hour, so I think we'll conclude now. And thank you all very much for your attendance and for your questions. Thank you.
Yeah, thanks very much, everyone.
Thank you.